Okay, so we're going to start with this. This is we're going to call this the basic idea behind solving basic trig equations. So a basic trig equation is kind of like one of these two here. It's where you got a single trig function on one side just by itself is equal to some value. Okay, or the sine of x here is equal to some value. You could also have tangent and other trig functions. Let's work with these two right here, and then we'll do the tangent. Okay, so this is the basic idea. Now we're going to do these to start with. We're going to use these special angles here. So these are values we recognize on the unit circle. They are they correspond to the special radian angles that we've learned about earlier. Okay, and then later we'll actually see how to do it when there's some other number. We're going to use the inverse trig functions in our calculator. Okay, so I'm going to do both of these to give you an example of each one here. So let's draw a unit circle and you can kind of see what's going on here. Okay, so the cosine of x, remember that is, the cosine x is referring to the x coordinate on the unit circle. So basically, you know, you go a certain angle, and then the cosine of that angle is the x coordinate on the unit circle. So the square root of 3 over 2 here for the x value, the square root of 3 over 2 is kind of like right about there. Okay. And the actual point here is square root of 3 over 2 for the x, 1/2 for the y. And if you remember, you kind of have to think about this here. The angle for that was pi over 6. Okay, so pi over 6 actually gives you an x coordinate of square root of 3 over 2. And so that's actually one of the solutions for this equation. If I put in there cosine of pi over 6, I would get square root of 3 over 2. Okay, but that is not the only solution to the equation, because there's actually an infinite number of solutions. Okay, so first of all, there's an infinite number because I could rotate around and stop there again, and I would get another angle that would give me square root of 3 over 2. I could rotate 2 times and stop, or I could rotate 3 times. I could just keep rotating, and if I stop at that place, I would get square root of 3 over 2. I could also rotate in the opposite direction, and I would get square root of 3 over 2. Okay? And so, the way we write that out here is I would have pi over 6, but then I'm going to add, this is an expression that gives me all those rotations. Okay? K here is actually, I'll write it down here. K is an element of the integers. And so by the integers, I mean -3, -2, -1, 0, 1, 2, 3, so on. Okay? And so basically, like if k was 0, that would be pi over 6. If k were 1, that would be the first rotation. If k were 2, that would be the second rotation. 3, that would be the third rotation. If I did k as a -1, that would be going backwards. Okay? And this would basically be an expression that would give me all of the rotations that are coterminal with this angle, pi over 6. Okay? But that is still not all of the solutions. Okay? And the reason is there's another point down here. I'm going to drop it down. Okay? And this point, this would be square root of 3 over 2, -1/2. And that angle here would also give me a solution to this equation, and that angle would actually be 11 pi over 6. Okay, so if I did cosine of 11 pi over 6, I would get, again, positive square root of 3 over 2. So that would be a solution, and you would also have all the rotations of that as well. So you would have 11 pi over 6 plus k times 2 pi. Okay? And that would be the solution set to this equation. And so for either the cosine or the sine, you actually are going to have 2 points on the unit circle that will give you 2 points from 0 to 2 pi that will give you the solution, and then you also have all the rotations. Okay, so the first time around the circle you get those 2 points, and then you got all of those rotations. So similar with sine, you will have 2 points and all the rotations. So let's look at this one. So the sine deals with the y-coordinate on the unit circle, and we have negative square root of 2 over 2. So now I want to know, when is the y-coordinate on the unit circle? For what angles is the y-coordinate going to be negative square root of 2 over 2? Well, that's over here. It'd be like this. Negative square root of 2 over 2. Okay? And so I would get 1 over here. Okay? And this angle here would be, that's one of the pi over 4, so this point over here would actually be negative square root of 2 over 2, negative square root of 2 over 2. Okay? And that would be like one of those the one of the pi over 4 angles, and this one is actually 5 pi over 4. 4 pi's over 4 plus 1 more, that's 5 pi over 4. Okay, and so that would be one of the solutions here. 5 pi over 4 plus k times 2 pi. Okay, so this would give me that angle plus all the rotations. Okay, but there's another one. Okay, and I'm not going to go up here because this is, I'm going to go across here because this is the other place. This would be a positive square root of 2 over 2 and negative square root of 2 over 2. Okay, so this would be the other place between 0 and 2 pi that would also give me a sine value, a y-coordinate of negative square root of 2 over 2. Okay, so this one over here is 7 pi, so that's 7 pi over 4. Okay, so this would be 7 pi over 4 plus k times 2 pi. And that's going to give me this one plus all the rotations either way. So that would be the solution set to that. So anytime you have a cosine equation or a sine equation, you're always going to, between 0 and 2 pi, you're always going to have 2 angles that are going to give you that solution, plus all those rotations of those 2. Okay, so what I would do is I would just draw, and you'll see me do this, just draw a unit circle every time, okay, and put those 2, find those 2 angles, put them on there, and then do all the rotations. And then notice if it's a cosine, okay, that's the x-coordinate, and it'll go up and then down to get the 2. If it's a sine, you're dealing with the y-coordinate, and so you're going back and forth, okay, to get those 2. And so those are that's the basic idea. You have all these rotations, okay, and that's these are with special angles here. Let me show you one other thing here, or let me show you a couple other things, and that is there are a couple. There's just for sine or cosine. There's an equation that's kind of a special case. It's and when you draw it out, you would see it. But let's try. This would be one of them. Sine x is equal to -1, and so the sine, right, is when the sine is when the y. You want to know when the y coordinate is -1, right? And that's this place down here. You get 0, -1. Okay. And so it would be like that, okay, and that angle there is 3 pi over 2, And notice here, that's the only place where the sine is equal to negative 1. Okay, there's not two places. It's kind of like, if you look here, for any of these values, you get two places, but when you get to negative 1, it's like that horizontal line is just tangent, right? There's only that one place where you get the value. So this would be 3 pi over 2 plus k times 2 pi. Okay, and so there would only be that one solution. But this is only when your basic equation is equal to negative 1 or 1. And that's true for sine or cosine. So if I had like cosine, we'll say cosine x is equal to positive 1, right? Well, the cosine x equal to positive 1, that's like right here. Okay? And there's just that one point on the unit circle, and the angle is actually 0, so you get x is equal to 0 plus k times 2 pi. And there wouldn't be another point where it's equal to 1. So that you could simplify that out to just this, and those would give you all, it'd be all the rotations of that, and that's when cosine x is equal to 1. So anytime sine of x or cosine of x is equal to negative 1 or 1, you would just have the one solution, but any other ones, you're going to have the two solutions. Okay, and that is the basic idea behind solving the basic trig equations. And I'll stop there, and then I'll do one involving tangent next.